Hello my dears. So now we are going to discuss about circuit breaker. So actually circuit breaker and relay that are in a circuit in together with, that are in together within a circuit. So I will I will tell you regarding the relay and its operation when we will talk about relay. But now we are talking about the circuit breaker. We are talking about the circuit breaker and its terms in the some certain terms associated with the circuit breaker, and also we are not focusing how the relay operate and how pick up current and all that terms will be later we will discuss. Now we are only discussing about the concept of circuit breaker and its action. So what is meant by a circuit breaker? As the name indicate, my dear, it break the circuit, that's all. It break the circuit. Then the fuse also doing the same function. The fuse also doing the same function. Whenever some abnormal condition in the circuit happens, the fuse itself blown, right? That also break the circuit. And what is the difference between a circuit breaker and a fuse? The answer is very simple. In a fuse, my dears, the making and breaking of circuit is done manually. That means once a fuse wire is blown, we have to manually rewire it and we have to fix it in the circuit. Then only we can make the circuit. The breaking can be automatically done, but the making is not doing automatically by the circuit, by the fuse. We have to make it manually. But in the case of circuit breaker, the making and breaking of the circuit is done automatically. Is done automatically. That is the difference between a circuit breaker and a fuse. So let's briefly explain the working principle of circuit breaker. See, my dear, this is the line. This is the load. That means here the load connected. The load may be motors, any industrial loads, or simply a rheostat. That also a load, or loudspeaker and anything. This is the load, my dear. And from source to load, this is the source. From source side to load side, the current is flowing. So initially the moving contact, these two are fixed contact, and one, this is nothing but the moving contact. The moving contact and fixed contact are contact with each other. That means they are together like this. See, the fixed contact and the moving contact are like this. Initially the load carries the current smoothly, it's running, no disturbance and all. It carries certain amount of rated current. Fine, very happy. And in the load itself, my dear, in the load line, that means the line of this connection, the primary winding of the CT is connected, and of course the CT having a secondary winding. That CT secondary is called the relay coil, my dear. That is called the relay coil. Relay means simply a coil. The function of the relay is nothing but it senses the fault. Relay means nothing but, my dears, relay, it senses the fault and tell to circuit breaker. Tell to circuit breaker. That's all. So the function of the relay is nothing but sense the fault and tell the circuit breaker, the fault is happening, you break the circuit. That's all. You break the circuit. That is the main function of the relay. That is the function of the relay. So now the relay coil is nothing but the secondary of the transformer, CT, current transformer, is called the relay coil. And there is a plunger. That plunger is nothing but an electromagnet like mechanism. Electromagnet. It can attract, it can plunging. Plunging means it can pull and it can release. That's all. It can pull or release. That's all. And this carries a load current, of course, the load current. If for any reason, my dear, there is a fault occurring in this line, a short circuit fault or any fault, what happens means If a breakage if occur in the line means safely what happened, safely it will be removed and no problem. But a fault is not at all breaking of the circuit, but a fault means a abnormal condition. Anything you can say it as a fault. Is it clear? A transmission line is fell down to ground means that is also fault. If two lines in contact with each other, that's also fault. So what happened if for any reason the current in the coil is increases, the current in the coil is increases, imagine that is a fault now. That is a undesirable condition. That's why it's called a fault. So what happened? The current transformer, this is the current transformer and this is the current transformer primary and this is the current transformer. The current transformer secondary now, the current is increasing here, proportionally the current will be increasing here also. This increasing current now, it will absorb or it will plunge it will move back, or it will move towards, that's the current, it's a move towards the plunger. So what happened? The plunger will come in, this connection will be completed. There is a battery now, so this connection will be what, my dear, complete. If this connection is completed, this is also a coil, so this coil will attract the fixed contact towards it, so what happened? This will be open. This is the before fault condition, and after fault, if it is energized, it will come back, it will move back. So what happened, my dears? There will be a break. Is it clear? So the circuit is now in break position. The circuit will be break. The story is over here. The story is over here? No. Actually, the story is starts now. Okay, so what happened then? See, my dears, that is the principle of circuit breaker we are going to discuss now. So what happened? As soon as the circuit breaks, what happened? See, suppose the circuit is not break means it carries a current. So we know that whenever a conductor carries a current, there will be a magnetic field associated with. If there is a magnetic flux associated with a conductor, we have L is equal to N phi by I now. Whenever there is a flux and I, there will be of course an self-inductance. We already studied that. Self-inductance of a transmission line, self-inductance of a single line, we all studied. So whenever there is a flow of continuous current in a conductor which is varying in nature, what happened? There will be a magnetic field associated with. So what happened, my dear? What happened if there is a magnetic field? So there will be an inductance. That means due to the inductance, there will be an energy half Li square, which is in the line initially. Okay, of course the load will carry some amount of active power and it will dissipate in the form of heat or any mechanical work done. Okay, anyway, but rest a portion will be a reactive power now. So that reactive power will produce a certain amount of energy. That energy is nothing but half Li square when the circuit is closed position. But suddenly, if due to the abnormal condition, if it is come back, this will be open circuit. So what happened? A sudden break of current will happen. See, my dear, this half Li square is nothing but the energy associated with the magnetic field. Magnetic field will be only exist when there is a current flow. You know that. But when there is no current flow, means suddenly it break the circuit, means there will be high potential difference exists between these fixed coins, my dear, because it's open circuit. Source is here, earth is here, so definitely there will be a high potential difference exist in between, and that 2 points will act as a capacitor. It contains charges, the earth contains charger, in between is a vacuum, so it forms a capacitor, and the whole energy initially it stored as the magnetic energy, that is half Li square, is now equal to half CV square. Equal to half CV square. Because both the energies are same. Is it clear, my dear? Is it clear? So circuit breaker is nothing but there is a conversion of this magnetic energy into electrostatic energy. Magnetic energy into electrostatic energy. So there will be what? A high electric stress E equal to V by D exists in between these two contacts, fixed contact. So what happened? Suddenly there will be an arc. This is happen in microseconds or nanoseconds time, my dear. While for explaining, I am saying it has a very big story, but this will happen in very few microseconds or nanosecond range. Okay, so so what happened, my dear? What happened? There will be what? A capacitance formed. So there will be an electric stress will create, and that stress will produce an arc here. An arc here. Produce an arc here. Produce an arc here. Is it clear? Is it clear? That means you can see in the real life also, when in the laboratory of electrical machines, DC machine or AC machine, when you start closing or a switch or start opening a switch, means there will be a spark. Now same arc will exist here also. And there is an important term you have to mention here, that see, the whole energy is stored in the magnetic field is converted into electric field. But this is the reactive energy, right? Reactive power associated with energy. But there are active power associated with energy also. Na? Where is that? Active power associated with energy. It is nothing but, my dear, the arc itself. The arc itself. That means here we can say that the inductive effect, is same as that of the capacity effect. The inductive effect is same as that of the capacity effect, and it will cancel each other. And the arc will have the nature of resistance. The arc will have a nature of resistance. So in theoretical, we talked about the RLC series, RLC series circuit. The same thing you can imagine here also. The same thing you can compare here also. L and C when equal, maximum current will be flowing. At that time, the nature of the circuit will be purely resistive. Same thing happening here also. Initially it was magnetic circuit, suddenly it changed into electrostatic circuit, and there will be a arc, because that energy should be active energy is also there now, that should be dissipated in the form of an arc. So a wonderful question you can expect to hear is that the power factor of the arc is unity. Very important question, my dear. Very important question. The power factor of the arc is unity. So arc is resistive in nature. That's all. Arc is resistive in nature. So the arc will be exist there. So if there is an arc, means there is again the continuity will happen. So we have to extinguish this arc, my dear. The word is very important. Extinguish. We have to extinguish the arc. This arc extinguishing is very much important in circuit breaker, because then only the circuit will be break. Otherwise the circuit will be in make condition. Arc also conducting, that's why. So what happened? There will be so many mechanisms so that you can extinguish the arc by forced air, by natural air, by SF6, by producing a vacuum. Many methods are there. We will talk about later, okay, about that. So that's all about the circuit breaker. And if the arc is extinguishable, we can perfectly say that the circuit is break. We can say that the circuit is in break condition. Okay, and whenever that abnormality of the current, that is the increased current, vanish. I mean, if the arc is existing, means if there is no the break, means what happened, my dear? The circuit will be isolated. the circuit will not be there. That means the arc will not be there, so that the circuit will be isolated. That means the load and source will be isolated. The load and source will be isolated, and we have to check for the fault. If there is, we confirm that the fault is removed, then we can again switch on the breaker. In the home itself we are doing the same thing now. In home itself we are doing the same thing. If something has happened there, the circuit breaker will trip, and what we have to do, we have to continuously thoroughly check in our home. Is there is any short circuit or something like that? Okay, there is nothing. Again we have to switch it on. If any fault exists there also, I mean in house, still there is some fault is there. What happened? The circuit suddenly trip. Nah? We try to on it, suddenly trip. So we confirm that array fault is there somewhere. Fault is there somewhere. We have to check thoroughly. You call an electrician and you will check, right? That will happen. Okay, so if the abnormal condition is okay, it is removed, means you can what? You can directly on it, or if the fault cleared in specific time, fault is clear in specific time, means itself it can what? Make the circuit. Itself it can make the circuit. Okay, the fault exists means if the continuous fault is there, means the circuit will be in trip condition. In the home also we can see the circuit breaker. The breaker will be, we can manually you can do that, or automatically it will happen. Okay, it will happen. Okay, so that's all about the circuit breaker. Okay, but in the case of a fuse, once it is blown, you have to take it back and you have to rewire it and you have to plug it. But now it is automatically, simply you do this, the circuit will be in contact. The circuit will be in contact. Okay. Okay, my dear. Okay, that's all. Is it clear? Actually, by doing our hand now, with our hand now, this moving contact is again we are trying to connect it. That's all. So that's all about the circuit breaker. Okay. In the next class, we will talk about some important terms in the circuit breaker. Okay. Thank you.